Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem N meetings in one room. So the problem statement says that you are given timings of N meetings in the form of start I, end I. These are the timings of the meetings. So start I represents the start of the meeting and end I represents the end of the meeting, the ith meeting, and we need to return the maximum number of meetings that can be accommodated in a single meeting room. So we just need to return the maximum number of meetings. All right, and we are given the constraint that only one meeting can be held in the meeting room. Only one meeting can be held in the meeting room at a particular time. So the note is also given that the start time of one chosen meeting can't be equal to the end of the other chosen meeting. So we can see the this example. So I would like to write the example here. So we are given the start array which is representing us 130585 130585. Now the end is given as 246799. 246799. And now meeting will come, meetings will be held. These durations of meeting is given, meeting 1, meeting 2. So different durations are given, starting and ending time, and we need to tell if this is a meeting hall, how many maximum number of meetings can be accommodated in this meeting hall, and one meeting at a time. All right, so what we can think of, so we need maximum number of meetings that can be accommodated in this meeting hall. So if we fill, if we just check the, normally if we try the uh, any example, if we try just hit and trial what we say, whatever we say, if we try, so some examples that if we had the meeting 1, so meeting 1 will be started from 1 and it will end to 2. Now we will come to next meeting, this duration is 3 to 4, and this 3 to 4 is can be held here because this is not overlapping with the previous meeting. Next 0 to 6, this cannot be held. If we just try to go iterate from very left to right, so this meeting cannot be held because this will interfere both the meetings. Next meeting 5 to 7, yes, this can be inserted here, this can be held. Next 8 to 9, this is also okay, we can just accept this. All right, so because these meetings, next meeting, this will just interrupt the previous meeting. So we can see here that just unknowingly we are iterating from left to right, and just we are checking if meetings can be held or not. So we can see in this case maximum meeting is coming 4, but what if this meeting 5,9 was before in the starting, so our maximum will not come 4, then it will reduce. So we need to think smartly how we can fill this meeting room, how we can accommodate maximum meetings in this meeting room. All right, so we can think greedily, we have to think smartly. So what we can do, if we sort the meetings by their end time, so if we sort the meetings by their end time, so what will it come? if I just create a pair of this starting and ending time, so I'm just filling ending time first and starting time second. Now if I just store it 4 comma 3, this is my vector of pairs where my pair dot first is the ending time and pair dot second is the starting time, because I will sort this array, this new array which I am forming, in ascending order. Alright, so this will be now 6 comma 0, this will be now 7 comma 5, and this will be now 9 comma 8, and this will be 9 comma 5. So now we can see that we have created this array, and now after sorting this we can, it will come 2 comma 1, and I think this will, after sorting this array will come just a simple change. This 9 comma 5 will come first and 9 comma 8 will come after. So after sorting this will come. What we can do, we can just keep track of the last ending meeting. So last ending meeting time, when was the last meeting was ended, and we have sorted the meeting from according to the end time. This will help us telling that the smallest the meeting which is ending fast, we can create more spaces for the new meetings to occur. So this way we can accommodate maximum meetings. So that's why I sorted this pair of vectors in ascending order according to the end time. So I can keep track of the last end. So my last end will be, I should take the first one. So the last end was ending at 2, and maximum meetings let's say, and I should keep let's say maximum meetings, I will keep it. So maximum meetings, this will be 1, because one meeting can be fixed in a meeting hall. Now I'm moving here. I will start from here. Alright, I will start from here. So let's, our I is here. I will check, is this meeting's starting time is after the last meeting was end, then only we can ask this meeting to come into my meeting room, then we can appoint this meeting. So its starting time is 3 and our last meeting was ended at 2, so this is greater than 2. So we can say that we can have this meeting also in our meeting room. So this will be increased by 1. Next, our I will be here now, and yes, before moving I will update my time when the last meeting was end. So last meeting was end was this. I can just say that maximum of, and instead of taking maximum of the last end and the current last end, because this is already sorted, I can just update it with 4. Now if I move to next, our I pointer will be now here. So my now current start time is 0, and I can see that 0 is less than the last end. So this meeting will interrupt the previous meeting. So I will just ignore it, and I will just move. Alright, now my I will be here. My current my start of the meeting is at 5 if I'm not wrong. It is 5 because 7 was okay, so it is 5 only. Now I will check when was the last meeting end. So this this meeting is starting after the last meeting was end. So I will say yes, take this meeting, have it, take it. Now our maximum meetings can be increased by 1, and last end I will update it with 7. Now I will move here. Now this will be 5. I can see the last meeting was ending at 7, so I can say that I will ignore this. I will not take this meeting because it will interrupt. Now my eye will be here. Now this meeting starting time is 8, and which is greater than my its starting time is greater than my last end meeting time. So my last meeting was ended at 7, so this time the meeting is starting at 8, so I will take this and I will update my last end and I will update my maximum meetings. Alright, count of maximum meetings, whatever we take the variable, and now my eye pointer will move and it will come out of the loop. Now I will return the count, that is 4, and this is our answer only. So what was the logic? I will just sort the pair of vectors in the ascending order with respect to ending time of the meeting, because the intuition is if my last meeting, if I can check when was my last meeting ended, I can ask new meetings to come. I can create a space for the new meetings. And why I sorted this? Because if my last meeting was ending early, then I can have more time and space for the new meetings to start. So that's why I started from the very less ending time, because this will help me. All right, so I will store the last end, when was the last meeting ended, and I will just check when is my new meeting starting, and when my new starting meeting will be after the last end, I will say take it. So this way I will keep track of my last end and the maximum meetings count, and I will return at the last. Now if I implement this, so what is said in the starting? So in the starting I said that I need to sort, and before sorting I need to store them. So I will first declare the size. Size can be start dot size or end dot size, whatever we want. I am creating vector of let's say pairs, let's say pair of int comma int, and let's call this vp. And now I am storing here the start time and ending time together. So now I am storing here, I will store according to the ending time. So I will store end comma I first, because my sorting will occur according to the end time only. And now my this array is ready. Now I will sort this vp dot begin comma vp dot end. Now what I said, now I'll just keep track of the last end. So let's suppose my last end meeting was the, I will take the first meeting's last end. So this will be v0 of 0, because ending time is at the first. So this is not v0 of 0, this is v0 dot first, because I'm storing pairs of vectors. Now what is my maximum count? So I have taken one meeting in count, so I will say that max count is 1, and in the constraints also the minimum and we can get is 1. So this is all right. Now I will move from the first 1th meeting or the second meeting to the last, and I will just check what is the current start of the meeting. So current start will be what? V of I dot second. Alright, now I will check that if this current start meeting is after the last end, I would say that take it and increase my maximum count, and now increase my maximum count also and update my last end also. Last end will be now according to this meeting only, so this will be v dot I dot first. Now do I need to do anything more here? Current start is greater than the last end, I've updated. And in the else case, if we don't find any current start less than equal to or I mean current start greater than last end, I will say just move on. So at last I would say that return my what? Max count. This will keep a store of my maximum meetings that can be accommodated in the meeting room. So if I submit this and check if I'm not making any mistakes, so I would check that I think it's taking time, so it means that we have done some mistake. So mistake is int last end. So the vector name is vp, not v. So I should take here vp. Anywhere else we are taking vp, we should take everywhere, we should take care of the variable's name. So we can see we have solved this problem now successfully. And if I tell you the time and space complexity, so we are sorting here first, so n log n time, then we are running one loop from I1 to n. So the time complexity can be big O of n plus big O of n log n. Alright, and according to the rules of time complexity, we can say the smaller one is neglected, and this will be big O of n log n. And space complexity, we are using this vector of pairs, we are creating this, but this is necessary for the question. So we can say yes, big O of space complexity is big O of n. So this was all about this problem. I hope you understood. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.